Hi, welcome to Competitive Cracker. So in this video, we will be discussing about some important aspects of CSIR NET Physics. So I hope you all have written the previous CSIR NET exam, which was in June. Okay, so I hope that exam was somewhat easy compared to the last exams. You know, the CSIR Physics offers a wide range of opportunities for all people, all the candidates. Those who have passed with JRF, they are most of them are doing their research in prestigious research institutes inside the country, like IITs and such research institutes. Okay, so CSIR also offers a wide range of opportunities in lectureship also. We should not consider the lectureship in the state of Kerala only, but you should aim for teaching positions in various other prestigious institutes which are located in various areas of India. So this also CSIR offers, if you pass with JRF after completing your research career, you can have better opportunities outside India also. After your research, after grabbing your PhD, you can have better opportunities outside India as a research associates, as scientists, etc. So your main aim should be to qualify with flying colors in the CSIR exam. You should have a better aim to have a good rank within 100. If you are having better ranks within 100, you will definitely be absorbed in one of the research institutes for PhD, and then you can have better opportunities outside India or inside also. Okay, so I request you to aim for a research, to aim for junior research fellowship. Okay, so junior research fellowship, junior research fellowship starting fellowship will be 31,000, plus you will be awarded HRA depending on the category of the city in which you are doing research, and also you will be given contingency grants. So the life will be in good colors for about 5 or 6 years, and there are chances that the grant fellowship will be increased in the coming years also. And once you have completed your initial 2 years in the research, you will be promoted to SRF, Senior Research Fellow. Then you will get a fellowship of 35,000 plus increment in HRA and increment in the contingency grant also. So definitely your life will be all set for 5 years, and then you will start to enjoy the various colors of life. And definitely it will be a great blessing if you are able to qualify JRF. So you should study in such a way that you should get JRF. So in order to qualify CSIR examination, you should have that much perseverance, that much concentration. So you should devote yourself 24/7 into your studies. You may have various other distractions. You will have some marriage functions or many other enjoyments will be there outside, but you should concentrate on your studies. How much your success depends on how much you are concentrated or how much you are devoted to your studies. Okay, so you should have a better understanding of problems. So you should study with a greater emphasis on the problems which will be appearing in the examination. So this will be a problem-oriented exam, you know it. So since it is a problem-oriented exam, you will be asked a wide range of problems which are included in the syllabus. So that problems may not be that much simpler. The B part problems will be much simpler, but the C part problems, it is of analytical nature. Since it is of an analytical nature, you should be able to apply your skills, your concepts into that problem, and then you should do the problems. So there will not be any direct problems. The concepts which you have studied, the base of that concept will have to be applied into that problems. So unlike other competitive exams, CSIR is a bit analytical in nature, and now since the competition is getting worse and worse, the level of problems has gone high. So we should be prepared to do the problems in the entire spectrum. We should be able to do the problems of simpler sections, part A, and you should be able to do the problems in the mid difficulty range, that is in part B, and you should be able to do the problems in part C, that is analytical nature. So this you should be able to cover this entire spectrum. So in this video we will be discussing some problems which could be asked in the examinations. So I request you to practice more and more problems to get well rooted in the concepts. So you should be clear with all the concepts, and the idea behind each problem should be made clear. So let us discuss the first one. See, a system with angular momentum L equal to 1 is represented by a state vector psi is equal to 1 by root 26 1 4 minus 3. What is the probability that a measurement of the x component of the angular momentum Lx in this state yields a 0 value? So we have a system, and that the system is represented by a wave function, and we are asked to find the probability that a measurement of the x component of angular momentum, that is Lx, of that state, when we measure the Lx value of that state yields a 0 value. So what is the probability? That is the question. So we should be able to calculate the probability of finding the particular eigenvalue of a system. So let us do this problem. See, we have to calculate the Lx value. So what is Lx? Lx is L plus L minus by 2, that we know. Lx is L plus L minus by 2. Okay. So also we know when J plus acts on the state L comma M, when J plus acts on a state L comma M, its value will be, what is its value? H cross under root L into L plus 1 minus M into M plus 1, and what is the state? L M plus 1, isn't it? And similarly, what is the value when J minus acts on the state L comma M? It is H cross under root L into L plus 1 minus M into M minus 1, and what is the state? L M minus 1, lowering operator. It lowers the state and it raises the state. This is a raising operator and this is a lowering operator. So angular momentum algebra is very, very important. You should study angular momentum algebra very carefully. Spin, angular momentum, spin algebra, angular momentum algebra, these things will be definitely asked. You will be given a calculation and you will be asked to find the probability for finding a particular eigenvalue. Okay, so various questions will be asked. So you should practice on this angular momentum algebra very carefully. Concentrate on that. It's very, very important. So we know for L is equal to 1, we are given the system is with the angular momentum L is equal to 1. So for L is equal to 1, what are the M states? What are the states? M is equal to -1, 0 and +1, right? So -1, 0 and +1. So L comma M states will be, what are the LM states? LM. So it is 1, -1, 1, 0 and 1, 1. So these are the states, correct? So then we have to calculate L plus and L minus. Then we have to calculate the LX. Clear? So what is L plus? L plus is a matrix. So to calculate L plus, this is state 1, 1. This is 1, 0. Hope you know this. 1 minus 1, and this is a brass state 1, 1. This is 1, 0, and this is a 1 minus 1. So you have to write cats as rows and brass as columns, and then you have to calculate the values of L plus based on this. Clear? So L plus, if it is L plus or L minus or J plus or J minus, never mind, it will have the same value. So first you have to consider 1, 1. If it is 1, 1, it is L plus, you have to raise the level. If the state is 1, 1, where it can be raised? It cannot be raised to another level. So all the values will be 0, 0, 0. Correct? And if it is 1, 0, 1, 0, M state is 0, M state can be raised to +1, right? 0 to +1. This is M value. So I have told you this is the M value. M is -1, 0 and +1. If here for L is equal to 1, we have this much M values. There are no other M values possible, only this much M values are possible. So if the state is M value is +1, if it is +1, it could not be raised further. So we have these values are 0, 0, 0. Correct? And then if it is 0, 0 state can be raised to +1 state. 0 state can be raised to +1 state, and all other values are 0. Correct? Why? Because J plus when act on L comma M will give you H cross under root L into L plus 1 minus M into M plus 1 L get L M plus 1. Correct? No other states will be retained. And similarly, J minus when act on L comma M will give you H cross under root L into L plus 1 minus M into M minus 1 L M minus 1. Isn't it? So, see, this is this. And then -1. If it is -1 state, if it is -1 state, -1 could be raised to 0th state. -1 could be raised to 0th state. -1 could be raised to 0th state. -1 plus 1, 0. Correct? So, it comes here and all other values are 0. Then you have to find the value. So, what is the value? If it is, see here M value is 0. So, H cross under root, L value is 1. So, 1 into 1 plus 1 is 2 minus, M value is 0. So, it is a root 2 H cross. So, it is a root 2 H cross. Correct? And then for M is equal to -1. For M is equal to -1, J plus when you act on J plus, -1 plus 1 is 0. Then it is also root 2 H cross. So this is the matrix. So this is the matrix for L plus. Clear? This is a matrix for L plus. Okay. So similarly, then for L minus, if you calculate for L minus, this is 1, 1, 1, 0, and 1 minus 1 and 1 1 1 0 and 1 minus 1. See, here it is m minus 1. The level will be decreased. If it is for m is equal to 1, the level could be decreased to, if it is 1, the level could be decreased to 0. So a value will come here. All others will be 0. And if it is a 0, 0 could be decreased to minus 1. 0 could be decreased to minus 1. All other values will be 0. So here it will be 0 and here it will be 0. And for minus 1, it could not be decreased further. So these all values will be 0. So what is the value? So if it is m is equal to 0, m is equal to 0, j minus act on j minus act on when it is acting on 1 0, it will give you h cross under root 1 into 1 plus 1 is 2 minus 0, it is root 2 h cross. Root 2 h cross. And if it is also root 2 h cross. This 1 0 is root 2 h cross. If it is 1 1, j minus 1 act on 1 1, it will be 1 minus 1 is 0. So h cross under root 2 minus 0. It will also be root 2 h cross. So you got you got two matrices, L plus and L minus. So L plus will be what is L plus? So you got L plus as 0, root 2 0, and it is 0 0 root 2 and 0 0 0, and L minus as 0 0 0 and root 2 0 0 and 0 root 2 0. Clear? So Lx is equal to L plus plus L minus by 2. So if it is you saw 1 by 2 is there, 1 by 2 is there, and from all these you can take a root 2 common. That we will discuss later. So see, it is a 0 plus a 0 0, and it will be root 2 and 0. Then it is root 2 here, then 0, and here it is root 2 and 0, root 2 and 0. So you have to add element by element. Okay. So root 2 could be taken common. Root 2 by 2, it will be 1 by root 2. So Lx equals 1 by root 2. Now 0 1 0, 1 0 1 and 0 1 0. So you got the value of Lx 1 by root 2, 0 1 0, 1 0 1, 0 1 0. So you have found out the value of Lx. So we have to, next we have to find the probability. So when Lx, x component acting on a state xyz, x component, the x component of angular momentum acting on a state should give you 0 eigenvalue. That is the question, and we have to find the probability. Correct? X component when acting on a state should give you 0 eigenvalue. Correct? So substitute for Lx. What is Lx here? 1 by root 2. 1 by root 2. And this is 0 1 0. 1 0 1. 0 1 0. Acting on the state x, y, z will give you 0 eigenvalue. Will give you 0 eigenvalue. Correct? So see, this is 0, so you should not consider this 1 by root 2. Or when you consider the here here I have purposefully omitted h cross. There was all h cross here. Root 2 h cross, root 2 h cross, here h cross, here h cross. They are all are there. Here you can take h cross common. Here it is h cross by root 2, 0 1 0 1 0 1 0 1 0. Here also there is a h cross, and since it is a constant, you can omit it. So when you multiply it, this is 0 into x plus 1 into y plus 0 into z is equal to 0. So you can get 0 into x plus 1 into y plus 0 into z is equal to 0. And next x 1 into x plus 0 into y plus 1 into z is equal to 0. And here also y 0 into x plus 1 into y plus 0 into z. The same equation will be repeated. No need to write. So from this you can write y is equal to 0, and here from this you can write x plus z is equal to 0. Y is equal to 0, x plus z is equal to 0. So x plus z is equal to 0 will give you x is equal to minus z. X is equal to minus z. So you can write the matrix, the column matrix as x. X is itself as it is, y is equal to 0, and what is z? Z is minus x. Z is minus x. So what is this? If you take if you put x is equal to 1, you can write 1, 0, minus 1. And if you normalize this, what is the normalization constant? 1 by root of 1 square plus 1 square. It is 1 by root 2. So you got 1 by root 2, 1, 0, minus 1. So you got the state as 1 by root 2, 1, 0, minus 1. Then you have to find the probability. So before finding probability, you should calculate a probability amplitude. Then the square of probability amplitude will give you probability. Is it clear? So first you have to find the probability amplitude. Probability amplitude. What is probability amplitude? Probability amplitude, the first state, that is psi I, psi f. Psi I, psi f. What is psi I? It is in brass state, so it is 1 by root 26 into 1, 4, minus 3 into psi f is 1 by root 2, 1, 0, minus 1. Is it clear? So 26 into 2 is 1 by root 52 into 1, 4 into 0 is 0, minus 3 plus minus 3 into minus 1 is plus. So it is 4 by root 52. 4 by root 52. So probably in your choices, they will give you 4 by root 52 also as the answer. So once you have calculated probability amplitude, you should not stop. By seeing the option, you should not get excited. It is wrong. Next, you have to calculate probability. What is probability here? Here the probability is modulus square of probability amplitude. Modulus square of probability amplitude. What is the modulus square of this? 16 by 52. What is then 16 by 52 could be shortened as 8, and this is 26, and this is 4 and 13. So it is what is the probability? 4 by 13. So the answer is 4 by 30. Clear? So the probability that the measurement of Lx yielding 0 eigenvalue is 4 by 30. Is it clear? So here first we have calculated the value of Lx. Lx is calculated as L plus L minus by 2. L plus L minus by 2. And you got the value of Lx as h cross by root 2. 0, 1, 0, 1, 0, 1 and 0, 1, 0. And then you calculated the eigenvalue equation. Lx acting on an arbitrary state giving you 0 eigenvalue. And then you calculated that arbitrary state vector, and then we measured the probability amplitude by multiplying inner product of the initial wave function and the final wave function. Never forget to normalize the final state vector. Okay, so this state vector has to be normalized, otherwise the answer will be another different thing. So never forget to normalize the state vector. So psi I into psi f, and psi I into psi f will give you probability amplitude, and the square of modulus square of probability amplitude will give you probability, desired probability. Is it clear? I hope you have understood this problem very much. See the next one. The ground level of a neutral lithium atom is doubly degenerate. The first excited level is 6-fold degenerate and is at an energy E above the ground level. Find the average energy of the lithium atom at temperature T. See, you are given a system. That system is having two energy states. The ground state is a 2-fold degenerate and the first excited state is a 6-fold degenerate. And you have to calculate the average energy of the lithium atom at a particular temperature. So this question comes from statistical mechanics, and from statistical mechanics definitely you will be given an arbitrary system, and you will be asked to calculate all thermodynamic potentials. Here you should be well advanced in the differentiation and integration. Everything you should be very clear with. The differentiation of log functions, integration of log functions and such other things. You should be able to play with this differentiation and integration. So then only the statistical mechanics problem will become easy for you. So in the statistical mechanics, the speciality of the question is the length of the question will be a bit large because they have to define the system. Once a system is defined, then they will ask, then they will come to the question. So you should read very carefully. The questions should be read very carefully. So each and every word should be understood, and then only you then only you should go to the next word. You should read word by word. A vague understanding of the question won't lead you to the correct answer. You should learn. You should study the question word by word, and then you should picturize the system. And once you picturize the system, first try to write the partition function for that system. I have told you the partition function in the classes. I have told you the partition function is just like the wave function that we have written in quantum mechanics. What is the specialty of the wave function? Wave function is just an identity card of a particular quantum mechanical system. In a similar way, in statistical mechanics, the partition function is the identity card of the system. Here, from this partition function, you can derive various properties of the system. Is it clear? So let us do this problem. See, the system, I have told you, you should read the question and picturize the system. See, I have read the question and I am picturizing the system. The system is having two energies, and the ground state, there is a ground state. The ground state is having 0 energy, and the first excited state is having energy E. The degeneracy of a ground state is 2, and the degeneracy of a first excited state is 6. Degeneracy is 6. Clear? So then if it is so, you have to find the partition function. You know partition function Z is equal to summation over I gi e power minus beta ei. Gi e power minus beta ei. So here the partition function Z is equal to here first state is having 2-fold degenerate into e power minus beta into energy is 0 plus next first excited is 6-fold degenerate e power minus beta into energy is E. Energy beta into E. So Z is equal to 2 plus 6 e power minus beta E. 2 plus 6 e power minus beta E. So I have formulated my partition function. So once I have formulated the partition function, I have to find the average energy of the system. How can you find the average energy of the system? Average energy is denoted as U. U is equal to minus dou by dou beta of log Z. minus dou by dou beta of log z. So what is it? U is equal to minus dou by dou beta of log z is 2 plus 6 e power minus beta e, isn't it? So what is this? Dou by dou, here it is a minus log dou by dou x of log x is 1 by x. D by dx of log x is 1 by x. D by dx of log x is 1 by x. So it is, I am writing it as 1 by x. 2 plus 6 e power minus beta e into differentiation of this. It is minus 6. It is a minus 6 into differentiation is with respect to beta. So it is a minus e into e power minus beta e. Have you understood? 1 by x log x d by dx of log x is 1 by x. 1 by x into differential of x. Differential of x is 1. So you have next you have to differentiate this also. Then only your differentiation will be complete. So when you differentiate this with respect to beta, this will be 6. There will be 6 into since it is with respect to with respect to beta, it is a minus e will be there into e power minus beta e. Clear? So the average energy will be minus into minus plus. It will be 6 e power minus beta e divided by 2 plus 6 e power minus beta e. Okay, so if you take 2 common from here, 2 and 6 will cancel, it will be 3. So u will be equal to 3e e power minus beta e divided by 1 plus 3 e power minus beta e. 1 plus 3 e power minus beta e. So if you divide both numerator and denominator with e power minus beta e, it will be in the answers. They will play with the answers. Okay, so I have got this as the answer. Then I thought of taking 2 common from the denominator. I took 2 common and I cancelled 2 and 6, and I got this. Then I looked in the I checked for the correct options. It won't be there. So they have played with this one. They have divided both numerator and denominator with e power minus beta e. So this will be 3e divided by 1 by e power minus beta e will be e power beta e plus here this will be 1 3. So this will be the answer. 3e divided by 3 plus e power beta e. So this is the value of average energy. That's why I have told you should learn to differentiate various functions. You should be very handy with the differentiations and integrations. I hope you have understood this. Clear? See, we have launched CSIR NET Physics course in the competitive cracker. So competitive cracker is a front runner in various competitive exams, especially competitive exams related to teaching fields like Kerala teacher eligibility test, CATET, state eligibility test, various set exams, then for CSIR and other UGC NET examinations. So since we have legendary results in these teaching field examinations, so we have launched CSIR NET Physics also for the aspirants. So those who wish to qualify CSIR NET Physics in the near future, or those who wish to qualify CSIR Physics by sitting in your comfort area or in your comfort zones in your home, you can definitely join competitive cracker. So competitive cracker is always ready to welcome you and always be there to help you. So I welcome you all so that we can study and prosper together. I don't demand that we know everything regarding physics. We are also students in physics. So we welcome you to be a part of our studentship, so that we both can prosper together. We both can study together. So we will be giving you various examinations. Daily workout examples will be given. You will be given daily homeworks, and daily assignments will be there. And then you will be having weekly exams also, covering stipulated portions. So timetable based syllabus will be covered. So we will be covering all syllabus with the help of a timetable. Weekly exams, then monthly exams, cumulative exams will be there, and then finally we will have different mock tests for the near preparation of CSIR Physics. So then you will have a 1 year validity for this course, so that you can cover 2 examinations with a single purchase. And also we will be giving you PDF notes, and this video lectures can be downloaded and could be viewed as many times as you want. So these are the specialities of our course, and also we will be giving you live classes also. We won't be satisfied with giving you the studio recorded classes in the application, but we should be able to interact. So for that we will be coming for you with live classes also. Those live classes we can interact, and so that you can clear your doubts more. So doubt clearance sessions will be there for or you can clear your doubts in any time of the day, so that you can message us through WhatsApp, or you can call us, or by using any ways you can clear your doubts. So you should not grow with your doubts. You should clarify and then grow. So you can clear your doubts anytime, but the live classes will give you extra questions, and will give you more exposure to the other areas of physics. Okay, so these are the specialities of our classes. So we welcome you to the competitive cracker, so that you can clarify, you can clear CSIR NET Physics with flying colors. So we welcome you all, and hope we can meet with more videos. And I request you to subscribe this NET channel, so that you can be more updated regarding the videos that we are uploading. Okay, so wish you all the best, and see you. Thank you.